Welcome all to Cultivating Caution series. How will technology shape the farm of the future? Before I introduce our great guest lecturers, I just want to talk about autonomy or automation for basically our agricultural fields. This is, we shouldn't consider autonomy to be a new thing that's happening in these coming years. We should understand that this is part of a long history of mechanization. So in the early 1900s, that's when our tractors were introduced. By the 30s, 40s, they became really common on our farm fields. And then those tractors kept developing, right? We kept adding more and more automated features to those tractors. And so this autonomy, in a sense, is just that next step for this automation that we've seen. Another important topic I want to talk about is that even though tractors came up all the way in the 1900s and really became common in the 30s and 40s, our focus on safety did not really begin until the 1960s. That's 1960s and 70s. That's when, for example, our rollover protective structures, or ROPS for short, was introduced initially as a patent, then as a standard, then finally as a OSHA standard in 1976. And that late focus on safety had a huge impact on injuries that we see in farms. So let's just take that tractor ROPS, tractor rollover protective structures, for example. Those ROP technologies, the whole goal of it was actually reduce the fatality rates in tractors. And even though we said the standard came up in 1976, by 1985, all manufacturers in the US started producing tractors only with ROPS. You look at 1993, we're talking about 30 years later, ROPS adoption was only around basically less than 40% on agricultural fields. And that's our big bar there that you see, our first bar in this chart that you see. And then even all the way to 2006 or 2007, ROPS adoption for tractors is only around 60%. So we're talking about 40 years later when this safety technology was introduced, and it still hasn't reached the complete adoption on our farms. And then you look at injury rates, comparing there. So this is, in this chart, that's our line, and that's the number of overturn fatality rates per 100,000 workers. So that's, when we do it by 100,000 workers, we're kind of trying to standardize it. And to give you a sense is that in 1992, there was overall around 20 deaths per 100,000 workers in all of agriculture. So our overturn fatalities represented about a quarter of all of those fatal injuries. And you could see that over time, over this decade and a half period, the number of injuries are declining, but not that significant. So now it's in 2006, 2007, it represents between 3 to 4 deaths per 100,000 workers. And what's there's another study not showing here that talked about that to actually finally reduce fatality rates significantly down, it takes adoption rates of safety adoption rates of over 80 to 85%. And I give this figure, and I know this is not up to date for the last 13, 20 years, but this is really important because I want to highlight that safety tends to lag with technology. If we don't put it at the forefront, we're going to see all these deaths, year after year after year. And it's a lot more expensive, a lot harder to tackle safety afterwards, which is in a sense where I'm passionate about this topic, is making sure that safety is at the forefront of this. In a sense, you could call it revolution. And it indeed is. So this is a map from a mixing bowl hub. So they're tracking all of these different companies that are popping up in different areas in autonomy. This is for crop landscape reduction. They have another figure also for dairy farms, because they're experiencing a similar evolution. And you can see there's a lot of these firms. You have some big firms that we see, like John Deere and so on, a lot of new startups. And a lot of new startups, they're focused on that production, right? Because if they can't produce, they won't exist. And that's where we come in. And that's some of the thoughts I'm having, is that how can we make sure that these new forms are safe for the farm? And this revolution is expanding rapidly. So this is from 2022. You can see all these companies in the different fields related to crop management, whether it's harvesting, taking care of the crops, or and different type of crops, whether it's row crops, specialty field, and orchards. And you just zoom in 1 year later, and it's a lot bigger field. So this is their mixing bowl hub data from 2023. 2024, it's going to be even bigger. And to just re-highlight why this is important, because a lot of times we're thinking, oh, autonomy equals it's going to be safer. Just the fact that people are not going to be on the field. I'm just going to give you just two quick examples, and then we're going to start introducing our wonderful speakers. The first is this great tech. It's fully autonomous. I guess you can't really call it a tractor, but it does a lot of that work. It works a bit differently. Instead of attaching an implement behind it, you attach an implement within it. And so this was demonstrated at the 222 FAIR conference. And to demonstrate it, they put a duct tape on the LiDAR sensor to highlight so that people can be around it while it's moving. And if it's that easy to disable the safety feature, right? What about if this is in the farming fields? How would farmers use this machinery? That's a really big question for me. And then also, what are the safety features inside the module itself? Because you can see that it has the LiDAR sensor, it has bumpers, everything on the outside. But once you're inside, that becomes a different question. Another study came for me when we held a workshop called Safer Ag Workshop, where we're trying to collect these case studies. So this was a company that purchased an autonomous pressure washer. And the idea is the cost of it was equivalent to the cost of a full-time worker. And they were told that, hey, this will save you one full-time worker. So they bought this machine and they implemented it. And they found out that, yeah, well, when it's doing the work, it does replace a full-time worker, but there's a lot of things you have to do to set it up, to clean it, to prep and all that. And when they did the math, they found out that it's actually reducing 10 to 20% of a full-time worker. They still need somebody else part-time to run this machine. So their solution to that was to, hey, let's save money and we have this guy anyway, let's send him into the barn with that pressure washer. Now there's standards for pressure washers. There's a maximum amount that the water can come out for the safety of the worker. When it's autonomous, you can exceed those standards because the idea is that you don't need a worker in that same space. And now that you're reintroducing the worker, instead of actually reducing the hazards, you've actually increased the hazards. And that's some things that we're seeing in the field. And there's other examples, other stories. I didn't want to bore you there. I wanted to have some great speakers that I wanted to bring you in today. So today I have Naveen, Dr. Naveen. He's a research scientist, and you could call him the executive director for the iFarm Farm of the Future project in Illinois. And we have Dennis Bowman, who is a digital agriculture extension specialist and the associate extension director for the iFarm. So we have great speakers. They're going to give you their perspectives on how this technology will impact safety. And we will start with Dr. Naveen.
Hi, everyone. Thanks, Salah, for the wonderful introduction. I hope everybody is able to hear me clearly.
Yes, we can hear you.
Okay, great. So today I'm going to speak a little, give an overview about how we are developing some technologies where we can use this technology to have this inbuilt caution in it, like safety features in it. how are we doing it in, we have a great test bed, and how are we doing it in, we have a great test bed, the iFarm test bed, which I'm going to introduce you, and which is going. Next slide, please. So iFarm stands for Illinois Farming and Regenerative Management. Okay, so this is where exactly our test is located. It is in the intersection of Race and Curtis. So we have a 110-acre test bed, and here in this particular video, if it is playing without any lag for all of you, so we have a 40-acre test bed assigned for digital farm, where we're deploying all the digital and modern technology to do the different farming management practices. Whereas on the right in blue, what you see, what I labeled as conventional farm, is the standard management practices which a regular farmer follows. So we would like to compare the different, both of them. What are the different yield, how the plants are behaving, how the soil quality is improving. So everything in this particular test bed, and we want to use regenerative practices. Basically, what I mean by regenerative is not just being sustainable, but something which is going to regenerate. So here we want to improve the properties of the soil so that it can be more nutritious, and it can, be helpful for the plants to grow well. Next slide, please. So this is a combined effect of different colleges at UIUC, in addition with our collaboration with our Tuskegee University in Alabama. So we have ACES, we have Agriculture and Biological Engineering, Animal Sciences Department, NCSA Center for Digital Agriculture, Crop Sciences, and Computer Science, and also a major part is Illinois Extension and the IC Institute. So together, all of these experts in different colleges came together to put this proposal of how we can use emerging technology to do better agriculture. And this particular testbed is being funded with USDA, NIFA, and out of the 76 land grant institutions, we are the only one who have been selected for having this testbed, the Farm of the Future grant. The core mission of iFarm is to develop an agricultural testbed where you can have this commodity crops. Not only commodity crops, you can also have livestock, and they're farmed using synergistic and regenerative practices. So this is our old school farming. Previously, our great grandmothers used to have this livestock and crop growing together, and then with the advent of machines, we moved more from polyculture. What I mean is growing multiple crops in the same piece of land to just growing one crop, what we call as monoculture or row cropping system. So with the advent of the tractors and machinery and wanting to generate more yield, we moved mostly towards this particular thing. But that led to several side effects, like you have a lot of soil erosion, you have a lot of nutrients being run off through this water table, and you have almost half to 70% of your time your land is fallow. You're not having anything growing on it, and the amount of organisms, the microorganisms which improve the soil properties, have been gradually decreasing. And this is one of the other reason why there are a lot of flooding also, because the soil has lost the property of absorbing the water even when there is greater rain. So if the soil can be actually improved using some of the regenerative practices, you can actually prevent all these side effects. So we have a major component of having an integrated extension activities, and Salah and Dennis are a key part of it, and they play a key role in taking this technologies to the farmers and getting the farmers' input and the feedback from them. And also we have an industry group, the industry partnership program also, where the industries can collaboratively work with the researchers at university on this particular test bed. So the basic idea is, we have several technologies which I'm going to introduce, and how we can use this together to make a better soil and increase the adoption of regenerative practices. So the way how we approach this is what I call as a control triad or general. Assume a regular farmer. How does he do? He just senses the plant is growing well or not, and then he plants. Basically, he thinks, okay, because the plants or the crops are under stress, maybe I need to put a little bit more nitrogen or nitrogen side dressing, or I have to remove the weeds. There is some decision making involved, and then finally, the farmer takes that particular action, using either of the machinery or any other means. He does that particular thing. So we want to replace, or not say we want to replace, we want to help the farmer by putting technology in different part of this triad and how that can be used for better farming management practices. Next slide, please. So now I would like to introduce the iFarm thrust. I would like to keep the reference of that sense, plan, and act triad. So basically, our first thrust is integrating remote sensing and IoT in precision farming. So again, mapping to the particular sense block in that particular triad, how the farmer senses, right? So you need different sensors on the farm. So we use multiple sensors. Some are in ground, like soil moisture sensors. Some are above the ground, like leaf area index sensors. And we also have other techniques of getting the health of the entire test bed. Like we do different airborne data collection, we do drone data collection, weekly data collection, and we have almost everyday satellite imagery. So through this different resolutions and the different levels of where we have these sensors, we can basically sense what is happening in our particular farm, right? That's the first thrust. The next thrust is the robotics thrust. Basically, is this can be linked to the act block in the triad, which I showed in the previous slide. Basically, the farmer decides that he needs to do weeding at one particular portion of the farm. How does he decide that? He decides based on the information what he got from the first thrust, the integrating remote sensing and IoT in precision farming. So he notices that, okay, there is the plant health in that particular portion of the field is not uh, great. So I need to put some extra nitrogen side dressing so that they can recover well. Next thrust. Yeah, the next thrust is rural internet connectivity and edge computing. So you may have your robots which can actually go to that particular location and do different tasks like side dressing, what I mentioned. In addition, they can also do cover cropping, they can do weeding also. But to do this decision part, you need some compute power, right? And for this compute to work, you need all of these things to be connected. The current problem with most of our farmlands is there is not much connectivity there. So we are exploring, bring your own network kind of thing where you can just get a trailer and you can enable network in a particular field. So we also work on rural internet connectivity and also edge computing using AI and machine learning techniques, using the data from the thrust one and also from thrust two, portion of thrust two. How can you make some decisions, and that can be directly acted by the robots with the permission of the farmer there. So the next thrust is integrating animals in the farm of the future. This is a very important part of, or which we call a unique portion of our particular test bed, is we want to have animals at the after harvest. For example, what we did in our first year is we planted cover crops using robots, and after harvest, we had these animals grazing on the test bed. So in this way, you can reduce the amount of cost for the feed for your animals, and also you get the manure and other things from your cows or any other animals in the field. So it improves the nutrition of the soil. The next thrust is technology access to smallholder and minority farming. So we just don't want all these technology development to be just accessible to farmers with huge farms. We want these technology to be accessible to minority farmers and smallholder farmers. So we are collaborating with Tuskegee University in Alabama, where the average farm size is 5 to 10 acres. So all our technology, as you will see in the coming slides, is very scalable. I would say it is scale neutral. You can use it on 5 acres, 1 acre, or 5,000 acres. So all our technology is developed in keeping this in mind. And then our last is this socioeconomics of technology adoption. Ultimately, this has to go to the farmers. That's when this is sustainable. So we have this socioeconomics of technology adoption trust, which works on how to come up with better adaptation strategies so that the farmers can adopt some of these technology into their daily farming practices. Next slide. So as I mentioned in our first sensing thrust, this is the soil moisture stations in the field. So we have these soil moisture sensors sensing at different heights, 5 meters, 10 meters, and 15 meters. And these are located in multiple portions of the field. So this is connected to the network, which I was mentioning. So you have the entire daily log of what's the moisture in your field in that particular location. So you don't need to actually go to the field every time to do the data logging and other thing. So you have this data continuously accessible to you. So in this time is when we didn't have any plants growing, from November to July. This is the last year data. So that's why you do here. Otherwise, you have the access of the soil moisture in different locations. Next slide, please. And next is the LAI monitoring in the field. So we have these crop eye cameras, where there are two sets of cameras, one placed on the ground and one at an elevated height. So one of them is looking from below the leaves, as you can see in the right bottom. You see the segmented upward photos. And then we have another two cameras on top of this particular mast here. And you can see the figures on the top right, the segmented downward photos. So in this way, you can actually do the segmentation and you can calculate the leaf area index. Currently, how the leaf area index is being measured is you have the people who are measuring going with the Lycor sensors in the field and trying to calculate the. Whereas with these sensors, again, it reduces the number of trips to the particular field. You have some trips is the time of installation of these sensors and maybe uninstallation of these sensors, during the time of harvest or something when you have these huge equipment operating in that particular field. Otherwise, you have access to this data on a continuous basis. Next slide, please. So you have these LAI data for the entire growing season. Leaf area index. You can see that the soybean is growing, and then once it starts to leave its leaves, you can again see that LAI reducing. Next slide. We also have the robots, which does in this particular one, they are cover cropping. So cover cropping is a very important regenerative practice, which is an accepted and agreed practice, where there are cover crops are generally planted post harvest, and because especially in Midwest we have the winter setting in soon. We harvest in October or November, and we have the winter starting in December. So they don't have much time for the cover crop to emerge. If we give enough time for cover crop to emerge, they can prevent soil erosion. They can actually reduce the nitrogen runoff, and they can also keep your from winds and other things. The topsoil is going to be preserved. So cover crop is an important thing, and in this particular video we see how these robots are able to carry around 80 pounds of seed, and they are navigating through the rows of corn autonomously, and they're able to broadcast the seed. So this enables, as you can see in this left figure, we planted it in July 25th, and August 12th, you already have the cover crop emerging even when the corn is standing. So this gives enough time for the cover crop to grow much and be well established. In this particular slide, you can see the difference between the biomass uh, of cover crops generated using the robots and using a tractor post harvest. So clearly, we can see that there is 1.5x, 1.5 times uh, more biomass when we plant it much early. So just having robots gives the advantages of planting in the cover crops much early and preventing soil erosion, reducing the nitrogen runoff and other things. And we noticed that the yield on both the fields have been consistent. It is 178 bushels per acre. The next year we had soybean on our test bed, and then we noticed that we can't have these robots going through the soybean, so we have these drones that do the cover crop seeding. The advantage of drones are they're much more efficient. They work well on soybean but not on corn because of the height. So these can plant on 20 to 25 acres per hour, the drones. Whereas on the left, we have these multiple robots. And if you use 3 robots, you can plant 10 acres per hour of cover crop seed. Whereas with the drones, with just a single drone, you're able to plant at 20 acres per hour. So there are pros and cons of both the things. The robots work well in corn and the drones work well in soybean. So this is some of the technology which we have deployed. As you can see in the previous video, you had these operators walking behind the robot. So that's, although the robot is autonomously driving through the rows of the corn, somebody has to be there just in case if there is some crash or something. So we worked on autonomy, improving the autonomy. Basically just uses a simple basic RGB camera and tries to get the key points, like which direction it has to head. And this robot can actually, without any crash, can run up to close to 850 meters. That's the average for 25 kilometers of. Next slide. Yeah, so we just did, we ran about 25 kilometers of the field, and we tried to do the analysis of when exactly is it failing. So the most cases are because of the corn gap. When there are no corns on the both sides for a considerable amount of distance, then actually the robot either switches to the another row or stops. That is a major failure mode which we observed. We tested it on 25 kilometers of this robot running and planting cover crops. This one is just showing how this can actually switch to a cover crop multiple robots. The same algorithm which we developed of the navigation thing works on different modalities of robots. So we also have these connectivity. So connectivity plays an important role. For example, in the cover crop video, you have seen these operators walking behind the robots. Whereas here in this particular video, what you can see, the operator is actually sitting in a trailer close to the field, and he's actually running the robot, and he can actually see the view of the robot in this left top. He's seeing what the robot is seeing, left and right, the cons. And okay, so that is user point of view, the right top, sorry about it. And the left top is where the teleoperator is sitting, and this is a third person point of view. Somebody is following in this particular video. They just showcase this, and we also get this GPS trace. So when there is a crash, the teleoperator will be notified and just do the crash recovery with teleoperation. He doesn't need to actually walk behind the robot. This enables whoever is doing the planting of the cover crops or operating the robots can actually, supervise close 3 to 4 robots at the same time. So thus increasing the planting speed and also enable safety of the operator. The operator is seated, somewhere else. in a much safe region rather than walking in the hot sun. So this connectivity also helps, as I mentioned, to access all the different sensors, drone videos, and everything to the central hub where the decision making can be taken. With this, I would like to show some of the key highlights. As I mentioned, in the Midwest, there is a unique crop livestock testbed with tiling and with fence. And we have extended from 80 acres to 115 acres from this year. Um, and we have this advanced data acquisition. We get almost daily LA soil moisture data. We get weekly drone data, and we get almost daily satellite images. This gives us a lot of data to enable us for better decision making. We want to remove the farmer from the difficulty of processing all this data. We have this AI and ML algorithms to give some suggestions to the farmers, a selected few suggestions, which the farmer can choose and do that particular thing. As I showed, we also did the drone cover crop planting. In addition, we also have this livestock management, herding using robots, which you see on the right side, where we have these dog-like robots used for moving the cows to different portions of the field where they have to feed, rather than having a operator moving the cows every time. So this dog also can be teleoperated, and we're also trying to see how this dog can autonomously try to move the herd of cows. Is one dog, or do we need multiple dogs? Is a legged kind of design better, or a wheeled kind of design better? So we had some interesting findings there. We had these leg robot. The cows were thinking that this is actually some kind of animal or a dog, and they were trying to smell it and trying to follow it to understand what it is. Whereas the wheeled robot is just like some other equipment for it. So they had a different interaction. The human robot, animal robot interaction here. Yeah. Next slide, please. So what we are trying to basically show is that technology can be used to improve the safety. We are still very much early in our journey to achieve this goal, but with some of the examples which I showed, the teleoperation of the robots and having multiple sensors to sense your entire field, we are moving step by step towards integrating safety into the technology which we are developing, rather than what Salah presented. The technology was developed, and then the safety was incorporated into it, and then there is this gap of people not adapting to the safety measures. So what we are trying to do here is trying to work side by side, incorporating safety into the technology what we're developing. And the sensors can be used to provide more information, and with remote sensing will give us better insights of what exactly is happening on your farm. And the under canopy robots will reduce the passes of large equipment, thus reducing the compaction of the soil also. So you need to use your large equipment only maybe once during planting and once during harvest. So this reduces the use of your equipment multiple times in the growing season on your field. Thus it reduces the amount of accidents or crashes with humans in the field. And connectivity is enabling us to scale these small robots to bigger size. Yeah, and we are also trying to use robots and drones for herding animals. This is still an ongoing work, it's in very preliminary stage, but we're just showcasing how technology can be used for enabling safety. And with that, I would like to thank my team. Next slide, please. Yeah, this is team from computer science, AB, agriculture and biological engineering, ECE, everyone, all around, crop sciences, everybody around the campus are working towards these goals. And so the great students and enthusiastic students who do all the hard work.
Thank you very much. Thank you very much, Dr. Naveen. I really appreciated this presentation and highlighting the tasks or what's going on at the iFarm. There's a lot of research, and it's really exciting trends, and I'm really happy to see that safety is coming at the forefront of these technologies. I'm going to transition to our next speaker, Dennis Bowman, who is our digital agricultural extension specialist, and he will be talking about the new technology in agriculture.
Thank you, Salah. But keeping the safety concept in mind, as well as we're looking at the adoption of some of the new technologies that we're working with at the iFarm and that farmers are looking at adopting in the near future. You brought it up earlier, but this concept that farming is always looking at what's the next technology that's going to improve things. So over time, there have been a lot of changes in agriculture. On this slide, this is my windowsill for my home office, and this is a collection of toy tractors that I look at as I'm working that kind of represents the tractors that I grew up with. Starting with the Farmall Super M up to Case 930 and an International 1086. So these are tractors that mean something to my history. But you can also see, over the time period of how things have gone, and the lack of cabs, the lack of rollover protection that you were talking about. My father and my grandfather were both survivors of tractor rollover incidents on our farm. So I do understand. And the latest technology that's hitting agriculture is this AI type agriculture and the autonomous machinery and the robots and drones. So we'll talk a little bit about that. The foundation, a lot of this is the software that makes it happen. And so we talk a lot about artificial intelligence and AI now. And there's a lot of things that AI can do. And one of those things is just basically party tricks. But a lot of it goes more deeper into how we can control this technology, how we can analyze data using artificial intelligence to help solve problems. But if you just want to look at a quick party trick from the AI, we have a limerick here of in the fields where the crops grow high, autonomous tech roams the sky. With sensors and gears, it reduces our fears, keeping farmers and yields safely nigh. When we talk about drones and automation and robots, the 4 Ds are often referred to. So if you have a task that's dull, dirty, dangerous, or dear, it may be a good place where autonomy or a drone or a robot may be something that could take over that task. Whether it's something that's just so dull and boring that you'd rather be doing something else with your time, and a robot can take care of that kind of a task that doesn't take a lot of mental power to do it. Dirty, just tasks that we don't like because they are just it's an environment where it's not comfortable to be in. And then dangerous, as we look at trying to make a farm worker's life better and safer, if we can take some of those tasks that are the most risky and use drones or robots to take care of those, that is a definite benefit. And dear is when that we've got something that's costly or expensive, and we could automate that and bring the cost down or make the productivity go up so that it's done in a more timely fashion. I know one of the first use cases I heard of a drone was with a large elevator that had a motor go out at the top of their elevator leg. And rather than send a climber up there to just go up and write down the serial number of the motor that needed to be replaced, they used a drone to go up and take pictures of the plate on the motor to get the information off of it, so that when the guy did need to go up there, he had all the parts he needed, and they could do the repair with just one trip. I do a lot of work with drones, and one of the things that has come up lately is spray drones. And as we look at the riskiness of occupations, we quickly see that farmers and ranchers are one of the most dangerous occupations. But one that rates above that is pilots. And those are the kind of pilots that do crop dusting and medical evacuation type things, med flights. And so those are the ones that are flying low and in all kinds of conditions where they're more likely to be in hazardous environments and run into crashes. So we do have that concern with our crop dusters and agricultural aviation. In 2023, according to the National Traffic Safety Board, there were 56 ag aviation accidents. And I've been doing these programs over the last winter in Illinois and Iowa, so I have the stats that there were 7 of these that occurred in Illinois and Iowa. And nationwide, there were 12 ag aviation fatalities. And Illinois and Iowa both had one of those, and those were helicopter pilots that ran into problems and ended up in fatal crashes. The FAA, when drones and this topic of spray drones first started to come to the surface, the FAA was very skeptical about this. The idea of something flying around the sky dispensing pesticides was something that caused a lot of caution to come to the surface. But as the FAA started to get some experience with it and worked with some folks on some pilot programs, they started to realize that there were some major safety benefits from the use of spray drones. There's no pilot on board in case there's an accident. So the risk of fatalities is very low, much lower. There's not hundreds of gallons of aviation fuel and several hundred gallons of pesticide on board to deal with if there is an accident. Drones typically stay within the field boundaries, which keeps them in unpopulated areas, basically. And they stay at low altitudes. They don't have to do these cross-country flights to and from the field to get from one site to the next. So they'll stay low. And then if a lot of our folks that are working in ag industry and small plots and specialty crops are familiar with these portable backpack type sprayers, and you put on a Tyvek suit and goggles and gloves, it's not a comfortable environment in the summer. Or if you decide not to put on the full Tyvek suit, you're going to end up getting some pesticide leaking on you or spraying on you throughout the process, or walking through wet plants that you've just sprayed. So the risk of coming in contact with that is pretty high for these type of applications. And a small spray drone can really take that risk out. And then you look at the cost. The cost of the drones. I've got the smallest spray drone, and it cost about $15,000. Altogether, with all the pieces, I was less than $20,000 for my full setup. A full setup with 2 spray drones, a big trailer, pumps and generators could run up to about $100,000. But when you compare that to the cost of crop dusting airplane, we're looking at a brand new crop duster coming in at a price tag of about $2.5 million. So that's where that deer might come in handy on that rules of drone usage. Safety-wise, in the time period that the FAA was evaluating this, they had no accidents with the drones, which was pretty remarkable. There is some, the drones do have sensors to know when people are around them, to try to prevent them from turning on. If anything's too close, they'll throw warnings. So there is automation in there to try to keep people protected, and they have avoidance on there. The latest spray drone on the market, the DJI T50, has 2 phased array radars built into the front and the back. These are when you hear about phased array radars, you start thinking military use and those kinds of things. But there's actually little rotating radar antennas and beacons inside those cans that will do a 360-degree analysis of the area for obstacle detection, including people, and to fly close to the terrain on up to a 50-degree slope. Pretty amazing technology. Another use of the robots, something simple like this little robot called a burrow that will work in conjunction with manual harvesters in vegetable and fruit production, where instead of the harvester, the person that's picking the fruit and using their eye to carefully calibrate which fruits are ready for picking, instead of them having to fill up a basket or container and then carrying it out of the field, the burro will come to them and then carry the produce out to the collection area at the edge of the field. So that skilled worker stays more productive and in the field. But if you're the worker, you might be wondering, would that have been a better time to take a break than to stay in here down in the foliage picking? But if they're getting paid by the basket, maybe this is something that gets them a higher income through the day if they're able to get a higher level of productivity and not spend as much of their time carrying things out to the edge of the field. So has to be evaluated on a case-by-case basis, I think. Naveen talked about our cover crop seeding robot, and it's pretty low cost. It doesn't have a lot of safety features built into it because one of our biggest goals has been to keep this as low cost as possible, using those low cost RGB cameras, materials that are relatively cheap, so that this when it gets to the marketing stage, it's something that could be affordable and be adopted by a wide range of different scale producers for different uses to do this. I know that I have had one casualty with the cover crop seeding robot when it ran over one of my drones and broke a leg off the drone. So not a big problem. It was about a $15 part to replace, but that was an operator error. And as we look at the robots, one of the things, and any autonomous technology, one of the things as you're trying to evaluate it is to realize that there are different levels of autonomy, and trying to understand, is this something that basically is remote control? Is it something where you can just start it and let it run? Do you still need to keep an eye on it while it's running? And can you control more than one at a time? So we have these different levels of autonomy, and a lot of that relates to how often do you have to intervene to keep the robot or drone on task. And so as we try to get that to that fully autonomous stage where it can run and get itself out of problems if it runs into anything, and work as a team. So we've got a lot of different pieces of robots and autonomy that are being used by the iFarm group, the phenotype camera robots, some of the little farming ag bots that are little garden plots that are all automated, that can plant and weed and water these small plots all automatically. The harvesting robots that can reach into canopies with a flexible and arm to reach behind things and pick fruit. A lot of things are being evaluated that have different levels of autonomy that they've been able to achieve to this point. So those were some of the things that I wanted to talk about. I'd be anxious to get into the questions and discussion here as we move forward.
Thank you very much, Dennis. I would love to welcome our participants to provide questions. And for our speakers, what are your thoughts about upcoming technology, or the safety implications of these technologies? And as you guys are writing these questions, let me just give you just a few announcements. First of all, I would like to thank the FarmDoc sponsors who've made this happen. They've been a great set of sponsors who have supported FarmDoc in hosting these educational programs. I also would like to thank the FarmDoc educational partners and getting these messages across. I would also like to invite you guys, the latest updates on this occur at i/farm.illinois.edu. Feel free to check it out and see some of the research that we're doing and some of our outcomes. Also, if you would like to stay up to date with what is going on, you can either use the website to sign up, or you can go to go.illinois.edu/ifarmupdates and sign up to get the latest updates for events and research that we're doing at the Farm of the Future. Since I've mentioned events, might as well tell you our latest event, upcoming event. This is a collaboration between our Center for Digital Ag and our Regenerative Ag team to host this Farming of the Future that we're going to do on August 15th, 2024 at the iFarm and Regenerative Ag Farms. So this is our title is Digital and Regenerative Ag Integration. And we're going to show you some of the very cool technologies that we kind of highlighted earlier and other technologies as well. Again, if you'd like more information on this event, just go to go.illinois.edu/ifarmupdates and subscribe. We'd love to keep sharing these results with you. I'd like to thank you for joining us. This is a Cultivating Caution series. It's a monthly series. Our next set of series will focus on heat illness, report from Illinois, and farm safety for youth in August. And just as a reminder, you can access all of these. The series are being recorded, and you can go to the farmdoc daily.illinois.edu to access them. They're available on YouTube, and feel free to join there anytime. Okay, so let's go to our Q&A. We have about 7 minutes. Let's start with our first question. So I think this is a question to ask Naveen. Dr. Naveen, is there any opportunities for individual operators to participate with testing with the iFarm team using the operators' farms?
Yes, I think that's there. Some of the technology which we are confident, for example, like cover crops, we actually allow the farmers or some of the operators to test drive it. And we also had a request from one of the farmer who actually works with the university also that he wanted to plant the cover crops on his farm, and he had a 20 to 25-minute session on how to operate the robot. Yes, if we are confident about our technology like cover crop technology and something else, and even networking, I think those kind of things we are very much open for operator to get trained and also learn. In addition, we have this iFarm University, which Salah is leading. And in that, we will develop these training modules more specific for each technologies.
Yes. Thank you, Naveen. You want to add to that?
Yeah, we also have another project called the iCover project, where farmers that are looking at trying to use the robotics or the drone seeding of cover crops and want to experiment with that might be able to get some cost share assistance to do that. So that's coming as a side, kind of out of the side of this project, is this iCover grant that's out there as well.
Thank you. Yeah, that's for sure. And by the way, we have our email addresses up here on the board. So for myself, for Naveen, and for Dennis, and we're all involved in the iFarm project, you can feel free to email us if you're thinking and you'd like to participate in any way. Now, our second question that we have is, Dennis, this is for you. So given that you had the front seat on that digital revolution that you've seen in the last 40 years or so, what emerging technologies do you expect to become widespread in the next 5 to 10 years?
Well, as I kind of covered in the presentation, I think one of the biggest ones that's going to be this big change is with the aerial application using drone technology. And right now, in some of these early phases of using this, the efficiencies have been somewhat low, but as we get more comfortable and the technology improves, the opportunity to do swarming with these drones, so where the operator can legally and safely operate more than one drone at a time, will increase the efficiency up to the point where I think we're going to see a lot fewer of the manned aircraft and a lot more of the drones out there in agriculture. And then with robotics in general, we've already seen the rapid adoption of auto guidance in the tractors and the farm implements. And I know I was out just this morning collecting some video for a project and put a GoPro 360-degree camera on the windshield of one of the farm tractors out at the research farm, and got some video of planting being done. And I also captured a little bit of video of the operator seeming somewhat bored as he was sitting in the seat with his hands off and just monitoring the screens. So I think we'll see that continue as things go forward.
And that's awesome. And so how do you think that's going to impact safety? You talked about, for example, removing the pilot increases the safety, but what about the people on the ground?
So I think one of the things, another area where the safety comes in is because of the rush for planting and harvesting, and the time and the tiredness that farmers get during this time of the year and the stress that they're under. I think things that can be done that reduce that stress to keep their emotions cooler and getting things done in a timely fashion, which lets the autonomy of the vehicles take over some of the drudgery of that so that they do not get quite as tired. And I know I talked to some farmers early on that were close to retirement when they first got guidance, automatic guidance systems on their tractors, and they realized that they were not as tired at the end of the day, and that they may not want to retire quite as quickly as they had been planning on.
That's a great example. Thank you. Naveen, so question for you. What do you anticipate to be the largest challenge in maintaining the safety of autonomous machinery?
Yeah, I think it's the education. For example, I think that should be the key part. For example, everybody knows about our traffic signals, right? It is there right from childhood. Everybody is trained. So there are going to be still some accidents, if people don't follow that. So I would not say autonomy is just going to remove all the accidents. There will be some cases where even if you equip your whatever autonomous robot or autonomous drone with all kinds of complex sensors, still there may be an edge case. So it is the education part, where the farmers, growers, the technologists, or the engineers who are developing this technology should play a key role in simultaneously educating the end users. It is going to take time. It's not going to be just within 6 months or something everything is known. So that will actually help making wide adoption of these autonomous systems, because people know that, okay, I should not go into this particular regions of this equipment because it cannot sense, it cannot see me. So if people are educated in that thing, I think we can reduce much more accidents or farm accidents related thing. That's the key thing. We should also simultaneously do the safety part, the safety training, along with developing engineering new systems.
I really appreciate the answer. We are at time, so we're going to close off at this moment. Thank you very much, Dr. Naveen. Thank you very much, Dennis, for coming on board today and showing us what does the farm of the future look like. Really excited for the next 5 to 10 years.
Thanks. Thank you, Salah. Thank you, Jim. And thanks, everyone.